Welcome to AsymCode. Ready to learn more about Python and coding? Hit like, subscribe, and let's get started. In Java, classes and objects are fundamental concepts of object-oriented programming, OOP. A class is a blueprint or template that defines the properties, fields, and behaviors, methods of objects, essentially acting as a blueprint for creating objects. An object is an instance of a class, meaning it is a specific realization of the class with actual values for its properties. For example, a car class might have fields like color and model, and methods like start engine or accelerate. When you create an object of the car class such as myCar is an object that can use the properties and methods defined in the car class. This allows for reusable, modular code that models real-world entities effectively. This example simulates a simple car management system using object-oriented programming in Java. The program defines a car class with attributes like make, model, year, and fuel level, which represent the car's properties. It includes methods for driving the car, drive, refueling it, refuel, and displaying the car's information, display info. The drive method reduces the fuel level based on the distance traveled, while the refuel method increases the fuel level but ensures it does not exceed a set capacity. The example demonstrates how to create a car object, interact with its methods to change its state, and display its updated information, simulating a basic car management scenario. Define a class called car. This is the blueprint for creating car objects. A class is a template that defines the structure and behavior, methods of objects. Declare variables, fields, for the car class. These variables represent the state of a car object and store its properties. Fields are used to hold the data about the object. Variable to store the car's make, for example, Toyota, Ford. This is a string type because the car's make is text. Variable to store the car's model, for example, Corolla, Mustang. This is also a string type, representing the model name. Variable to store the year of manufacture, for example, 2020, 2021. This is an int type because the year is a whole number. Variable to store the car's fuel level, in liters or percentage. This is a double type because fuel can have decimal values. Constructor to initialize a car object with specific values when it is created. A constructor is a special method that is called when an object is created. It sets the initial values of the object's fields. This refers to the current object being created. It helps differentiate between the parameter, input, and the field, instance variable, with the same name. Set the make of the car, for example, Toyota, from the parameter to the objects field. Set the model of the car, for example, Corolla, from the parameter to the objects field. Set the year of the car, for example, 2020, from the parameter to the objects field. Set the initial fuel level of the car, for example, 50.0 liters, from the parameter to the objects field. Method to simulate driving the car. This decreases the car's fuel level. The method takes distance as an input, in kilometers, and calculates how much fuel is consumed. The fuel consumption rate is assumed to be 0.1 liters per kilometer. So, we calculate the total fuel consumed by multiplying the distance by the consumption rate. Fuel consumed in liters. Decrease the car's fuel level by the amount of fuel consumed during the drive. The car's fuel level is reduced by the calculated fuel consumed. Ensure that the fuel level does not drop below zero. A car can have negative fuel. If the fuel level is less than zero, set it to zero because the car can't run without fuel. Output the new fuel level after driving. This shows how much fuel is left after driving a certain distance. Method to simulate refueling the car. This increases the car's fuel level. The method takes amount as an input, in liters, and adds it to the car's fuel level. Increase the car's fuel level by the amount of fuel added during refueling. Add the given amount of fuel to the car's current fuel level. Ensure that the fuel level does not exceed the maximum tank capacity, which we assume is 50 liters. If the fuel level exceeds 50 liters, set it to the maximum capacity, 50 liters. Output the new fuel level after refueling. This shows how much fuel the car has after refueling. Method to display information about the car, such as make, model, year, and fuel level. This method does not take any parameters. It simply prints the details of the car object. Print out the car's details, make, model, year, and fuel level. Display the car's make, for example, Toyota. Display the car's model, for example, Corolla. Display the car's year of manufacture, for example, 2020. Display the current fuel level of the car. The main method is the entry point of the program. It's where we can test our car class. Create a new car object named MyCar using the car class constructor. We pass the values for make, model, year, and initial fuel level as arguments. Call the displayInfo method to print the details of MyCar. This will show the car's details like make, model, and fuel level. Call the drive method to simulate driving the car for a distance of 100 kilometers. The car will consume fuel as it drives. Call the refuel method to simulate refueling the car with 30 liters of fuel. The car's fuel level will increase. Call the display info method again to show the updated details of my car after the drive and refuel. This will show the new fuel level after driving and refueling. Now run our code. Thanks for joining me. Like and subscribe for more exciting content.